Okay, so for this question, a particle P moves along the x-axis at time t seconds where t is greater than or equal to 0. The velocity of P in the positive x direction is v. Okay, so we've got time going along here, velocity along our y-axis. And then we're given our equation for v, so v is t minus 3, 8 minus t. P attains its maximum velocity at time t seconds. The diagram shows part of the graph of the motion of P. Part A, state the acceleration of P at time t. So right here, at a turning point, the acceleration is 0. The velocity is at its maximum here. You can tell that by looking at the graph. The velocity is at its maximum. Whenever the velocity is at its maximum or minimum, the acceleration is 0. So it's just 0 ms minus 2. After that, part B. In this question, you must show detailed reasoning. Determine the value of t. Or, in effect, what number is t going to be when the acceleration is 0? And so what we need to do is we need to find the acceleration. Now, to find the acceleration, we can differentiate the velocity, because when you differentiate velocity with respect to time, you get acceleration. And so that's what we're going to do just here. But to start with, I'm going to expand out that bracket so it's slightly easier to differentiate. So if we expand out this bracket here, so t, and then we get, what are we going to get? We're going to get 20, no we're not. We're going to get 8t plus 3t is 11t, like that. We are going to get minus 24 minus t squared. And then if we expand this out, we get 11t squared minus t cubed minus 24t. So what we can do now is we'll differentiate this, because when you differentiate velocity, you get acceleration. So dv over dt equals 22t minus 3t squared minus 24. And the key thing we need to know is at this point, the acceleration is equal to 0. And so I set this equal to 0. So 0 equals 22t minus 3t squared minus 24, like that. Now, I probably, just because the question says you need to show detailed reasoning, I'm going to go about factorising this rather than just putting it into my calculator. So if we go about factorising and solving this, first of all, I would kind of divide or multiply by minus 1. So you get something like 3t squared minus 22t plus 24, like that. And then in terms of how this is going to factorise, it's going to factorise into two brackets like so. So we're going to get 3t and we're going to get t. And then we're going to get minus 4 and minus 6, like that. If we solve both of those, and you can use your calculator almost to help with like the reverse factorising here. But if we solve this, we're going to get t equals 4/3. If we solve this, we're going to get t equals 6. So in terms of t at this particular point, well, this point here is going to be your 4/3 point, and this point here is going to be 6. So t is 6. Finally, for part C of this question, find the total distance, we're thinking about distance now, that P travels between times t equals 0, which is here, and t equals t, which is here. Now what we've got, the original functions of our velocity. To get from velocity to distance, we need to integrate. So if we integrate velocity with respect to time, we get to displacement. And so that's what we're going to do. We're going to integrate our velocity. So we've got our velocity just here, and we're going to integrate that with respect to t. So when we do that, we're going to get 11 t cubed over 3 minus t to the power of 4 over 4 minus 24t squared over 2, which just becomes 12t squared. We don't need to have a plus c because we're integrating between limits. Now, in terms of what our limits are going to be, well, we're going to need to integrate between here, which is when t equals 6, and this point just here. Now, in terms of that, this point is going to be 3, because using our original function, it's got a root at 3, so this point here is going to be 3. So we're going to integrate between 6 and 3. We're also going to integrate between 3 and 0. You can't do this in one go because it crosses your x-axis. If we do this now, so we're going to integrate here, so 11t cubed over 3 minus t4 4 minus 12t squared, like that. So the first thing I'm going to do, and I'm going to write down here, which isn't ideal, but we'll make it work. The first thing I'm going to do is substitute in 6 into this expression. So when you substitute in 6, oh, it's being slow. So when you substitute in 6, you get 36. And then when you substitute in 3, let's just work this out now. So when you substitute in 3, you get minus 117 over 4. So remembering we're minusing a minus just here. Then after that, we're going to integrate between 3 and 0. So when we substitute in 3, we get minus 117 over 4. When we substitute in 0, we get 0. So then we're going to work out both areas and then add them together. So this bit just here, so 36 minus 117 over 4 gives us an answer of 261 over 4. So this area just here is 261 over 4. This area just here comes out in your calculator as being minus 117, but that's only because it's below the x-axis. In real life, it's positive. So this here is positive 117 over 4. And so finally, to get the actual area, we need to do this plus this. And so when we do that, when we add them both together, we come up with an answer of 189 over 2, or another way of saying that, 94.5. So I'd probably give it as 94.5 meters.